And want to welcome you all tonight to the Scoop on Skunks with Dr. Rem Moll. And this is a program hosted by the Harris Center for Conservation Education, which is in Hancock, New Hampshire. And if you're not familiar with the Harris Center, it's a nonprofit that works to protect more than 25,000 acres of land in southwestern New Hampshire. And we help people fall in love with the natural world, people of all ages, people from little kids all the way up to people in retirement centers. So all ages, education, conservation, research, and land protection. So most of our land is open for recreation, hiking, biking, fishing. So I hope you'll check us out online and come to visit us in person. In a minute here, I'll put the link to our website in the chat, and we have lots of events online like this one, and also in person. So hope you'll find us online. So now I'm going to pass it over to Dr. Moll, who's going to talk to us about a really interesting mammal in our midst. So take it away.
All right, thank you very much, Karen. Let me share my screen here. I will just, I'll press on and assume everything's working unless I hear someone tell me otherwise. So yeah, thank you, Karen, and thanks to the Harris Center for inviting me. Thanks for everybody for coming. I'm very excited to talk with you all a little bit about mostly the striped skunk and some other wildlife as well. I'll preface this by saying that I'm a broadly trained wildlife ecologist and have been getting into some skunk research in the last few years. I don't know that I'm the foremost skunk expert in the world, so a little bit I'll be learning alongside with you tonight. So what I'm going to do over the next 40 minutes or so, I have kind of 4 sections. I'm going to give some background about general wildlife in what's might be called the Anthropocene, which I'll define here in a second. Then we'll talk about skunk natural history. Then I'll go over a recent study that I was involved in across the USA on skunk abundance, and then end with a little bit about skunks here in New Hampshire, in the Granite State. So I run the Wildlife Modeling and Management Lab at UNH, at the University of New Hampshire. Sorry, I'm just going to move my bar here a little bit. And the modeling part in our lab's name is for statistical modeling. So we do a lot, we work with data a lot and do a lot of statistical analyses. We study a variety of species. We often focus on small, medium, and large mammals, including red fox, as in our little icon there. Bobcats, UNH, our mascot is the wildcat, so we study wildcats. White-tailed deer, and fisher cats, among other species. So thinking about wildlife ecology and conservation in the quote-unquote Anthropocene. The Anthropocene is a term that some people have given to the current geologic epoch that we're currently living in, which follows the Holocene. And the idea is that the anthro part is connected to humans. And this current age that we're living in is really characterized by human domination of the globe and ecosystems. One of the things that's happened in recent history for the first time is that most humans now on the planet live in cities. So this graph is showing the population of humans across the world, and the red line is humans living in urban areas, the blue line is humans in rural areas. And you can see that the lines crossed each other for the first time in about 2010, which means that for the first time in human history, most humans are living now in cities, which has implications for ecosystems as well as the human experience of nature. One of the results of that is that urban sprawl is a major force on the landscape, changing the landscape, and it's one of the leading causes, perhaps the single leading cause of species endangerment in the USA. There are certainly many other things to be concerned about: climate change, pollutants, toxicants, things like that. But urban sprawl and the landscape change that comes with it is one of the main drivers of species endangerment. Of course, along with that come light and noise pollution, which can alter wildlife behavior, reproduction, and survival. One of my colleagues here at the University of New Hampshire, Dr. Karina Sanchez, studies how American robins are responding to light and noise pollution in cities. One of the things we look at in my research group here as well is different aspects of the urban landscape. So we can think about a big metropolis that has highway systems. We can think about suburban sprawl, shown in this picture. We can think about humans ourselves and how our activity can change wildlife behavior, as well as urban parks and the role that green spaces in the midst of urban development play for wildlife. So a couple of questions that we're interested in, and I will connect this to skunks shortly, is in this age that we live in terms of wildlife, who are the species that are winning and losing, and who's affected positively and negatively by human landscape change? And why are some species thriving in human-altered environments and others not? So these are research questions that my research group here at UNH think about a lot. And we can kind of think about species in three general categories, wildlife. There are human avoiders, which would include things like pumas or mountain lions, prairie chickens, maybe some migratory bird species like scarlet tanagers. There are adapters, which could include species like, that might show up at the bird feeder, like cardinal, white-tailed deer, coyotes. And then there's urban exploiters. These are species like starlings and house sparrows and house mice. And skunk are an interesting species within this mix. I would place them somewhere in the middle, not necessarily avoiders. Some might argue they're exploiting certain elements of urban environments, but I would classify them somewhere in the middle as adapters. A little bit more about some of these small to medium-bodied predator species, mammals. There's a paper about a decade ago that Laura Prue published called The Rise of the Mesopredator. And what this paper looked at is it looks at a bunch of mammal species and how large their geographic range was before European colonization of the United States and then after. And that's what these two columns are here. So before European colonization, many of these apex predators, which would include things like wolves and cougars and bears, were larger than their current ranges. And so many of the apex predators' ranges have shrunk dramatically over the last 150 years or so. One of the results of that is these mesopredators, which are smaller, meso standing for medium or middle, things like coyotes and foxes. They compete with these apex predators that are at the top. And with the reduction of some of these apex predators, that released some of these mesopredators to thrive. And so you can see large percent increases in a lot of the ranges in these species in the mesopredator category. Where skunks would fit into this, we would place skunks in the mesopredator category. Skunks are generally considered carnivores. They're in that taxonomic order. They have, interestingly, basically stayed the same in terms of their range pre and post European colonization and industrialization of the United States. So that's really interesting because they've basically been resilient throughout this time period of dramatic landscape change. And before we move on to natural history, that's kind of a theme that we'll run through the rest of the talk, which is skunks occupy this really fascinating, unique kind of role in the wildlife community. So let's talk a bit about skunks. Well, there are a number of skunk species in North America. We have the western and eastern spotted skunks. These are very cute little animals. They're smaller than the striped skunk. That's the most common one. The eastern spotted skunk, you can see here in these designations, these are IUCN categories of conservation. And the eastern spotted skunk is listed as vulnerable. And there is some conservation concern around the species, particularly in the Midwest, that their populations are declining. There's a lot of research looking into why. We don't have a really great handle on that at the moment. There are two other skunks that are on our southern border and range into Mexico and Central America. That's the hognose skunk and the hooded skunk. Both of them are fairly large. The hognose skunk is quite large, can go up to 2.5 feet long. And not a lot is known about these two species. There's not a lot of research on them. But today's talk will focus primarily on the striped skunk, which is Mephites, scientific name. That ranges all throughout North America and is a very common species throughout much of its range. It's a species of least concern in terms of conservation status. How did this skunk arrive? Well, many millions of years ago, a couple million years ago in the Pleistocene, is our earliest record of skunks in what's now the United States, in Nebraska. For a while, people thought that skunks were endemic or only occurred in North America, but some recent evidence has suggested that they were elsewhere as well. And so what happened was, from that early time period, they expanded to the south, into the west, into the east, and eventually into the northeast following the retreat of the Wisconsin Glacier, which is shown here on the right. So this blue area is the Wisconsin glaciation event. And so in this time period, which was in the Holocene, 10 to 100,000 years ago, all of where I am at now in New Hampshire and much of North America was very cold, covered in ice, and there was boreal forest, conifer-dominated forest, all throughout this region here. And as that glaciation retreated northward, many species colonized what's now northern United States, including skunks. And a bunch of genetic analysis has been done to try to figure out how exactly this happened. There's a bit of mystery to it, but it seems as though the original skunks here moved south, and then a clade moved to the east, down into the southeast. Another clade moved west and up around the Midwest and into where we are now, here in New Hampshire. So there's a bunch of different events, and there's a lot of genetic diversity in our current skunk population. Taxonomically, in terms of their evolutionary relatives, it was thought for a while that skunks were closely related to mustelids, to the weasel family, so badgers and otters. But more recent work based upon genetics and molecular techniques have actually placed skunks in their own taxonomic family, the Mephidae here. And it seems as though one of their closest relatives might actually be the red panda, rather than the badgers and weasels that we thought before. And again, this kind of highlights that skunks, they do their own thing. They are their own unique species, which is very cool. As I said, here's their range throughout North America. They're pretty much everywhere. There's maybe a pocket in the deserts in the west where they're less present. It's interesting, whenever you look at a species range, it's interesting to think about like what's causing the limits of those ranges. And here we have a southern limit down on the bottom and a northern limit on the top. So why are they not able to move beyond those limits? Well, in the north, I think it's almost certainly climate. They can't withstand those cold, long winters, and so that's the limiting factor there. In the south, it's a bit less clear. And there hasn't been a lot of explicit work into this that I know of, but I think it might have to do with those two other species that I mentioned earlier that are inhabiting Mexico, the hognose and the hooded skunk. And those species are similar in body size to the striped skunk and would compete with them for food, for resources, for dens, and so that perhaps is limiting their southward range limit. What do they eat? So skunks are a true generalist species. They eat anything, and it varies a lot by season, whatever's available. So probably the thing they eat the most consistently are invertebrates and insects and bugs. They favor beetles and crickets and the larvae of moths and butterflies. They'll also eat vegetation. They'll eat agricultural products like corn. They will hunt and eat rodents, like the white-footed mouse, the meadow vole shown here. They'll also take eggs. They'll take eggs, particularly ground nesting birds like turkey, quail, waterfowl. Eggs can get taken as well. They'll also scavenge and eat carrion. And if anybody has seen these marks in your yard, you might know that they will also hunt for earthworms in our residential lawns at night. So in summer, and this usually happens in the summer, if you go out one morning and suddenly these mysterious holes appear in your lawn, it's probably the evidence of a skunk coming out at night and looking for food. So I think this is a good point to pause for a brief second, and I'm just really curious how many people here, and you can just put, this is going to be chaos, but it'll be fun. You can just put yes or no in the chat. How many of you have or have had a skunk in your residential property within the last couple of years? One no, so lots of yeses. We got an 81. I don't know what that means. Maybe there's 81. So yeah, a lot of yeses. By far, the most yeses, a whole family. We had one last year in our backyard in a pretty urban area in Dover, New Hampshire. Yeah, so yeah, so we all are familiar with these. Oh, pet skunk, that's fun. There is a fairly robust pet trade that I don't know much about with skunks. I'd be curious to hear about those experiences someday. Cool, so thanks for that. So probably a lot of you have seen something like this in your yard. All right, so I'm gonna continue on with a bit more natural history. So that's what skunks eat. Well, what eats a skunk? Not that much, turns out, because of their ability to spray. They are not very favored by predators. Things like coyotes or foxes could kill and consume a skunk, but they tend not to. And so this is an interesting study that I'm showing here, results from by Prange and Gert in Ohio. And basically what they did is they had radio tracked skunks. They had collars on these skunks that they tracked their locations. And they simulated coyote presence. They put out urine, they simulated coyote howls within the territories of the skunks and basically saw if the skunks reacted at all to those coyotes, and they didn't. So you can see the black line is before the treatment, the gray is during, and the white is afterwards, and you can basically see that these bars are all the same. Skunks don't care. They are very chill, they have a great defense, and they are not bothered by smelling a predator that could potentially attack them because they do have this very pungent defense mechanism. So we should have tested these, Karen. Hopefully these will work. I want to show a couple of videos. I don't think you'll be able to hear them, but I can kind of narrate. So this is, do you hear the video? No, okay. So this is in Calgary, Canada, and that is a mountain lion being chased off by a very small skunk there on the side of the road. If you look closely right there, I'll back it up just a second. Are you able to see, is the video working? Can you see the video? Yeah, okay. You can see the skunk will stamp on the ground here as a warning, and it's got its tail up. So it's letting that mountain lion know that it means business. This mountain lion is having a stressful day because it's dealing with this truck on the side of the road that's looking at it, and the skunk that is also harassing it a bit. So, I mean, this is a mountain lion. This is the very, very top of the food chain. And it's quite clear from these interactions who the boss is. So that's the skunk chasing off the mountain lion. So not a lot of mammalian predators will attack skunks. The one predator that will take skunks, or predator group, I should say, is birds of prey, especially owls, like the great horned owl here. And the thinking behind this is that the owl's sense of smell is less sensitive to the skunk odor. Owls are also nocturnal. They're active at night, just like skunks. And so this is the one type of predator that will take skunks. So what does cause skunks to die? Well, this is a figure from a review paper on different mammals and what their mortality sources were. So if we look over here at skunks, we see that there are two columns here. There's rural skunks and urban skunks. And what is causing their deaths? Well, the main two factors are the white, which is disease, and the black, which is cars. So vehicle mortality and disease are pretty much, by far, the main things that are causing skunks to die in the wild. This right here, the darkest gray, is predation by other animals, and you can see that none of that appears in the skunk column, whereas it does in some other species. So they really have great defenses against natural predators, but not cars. In terms of winter hibernation, they're not true hibernators. They will build up fat in the fall. They'll feed a lot and build up that fat, and they kind of go into a state of reduced activity. If you have them around your house, I know this happened to us at our house in Dover, in urban areas where there's maybe more food, or that it's a bit warmer because of like the urban heat island effect, or they have good cover, they will be active. And so we had a trail cam in our backyard last year, and there was a skunk every night in the winter doing its routine walk by the camera. I don't know where it was feeding, but they might be feeding, on infrastructure, people's barns, people's sheds. There might be more rodent activity. Perhaps there's things like compost piles that might serve as food sources for them. So they're not hibernating, and in urban areas, that's especially true if there's a food source. It really comes down to food. And then they ramp up that activity again near breeding season, which occurs in the late winter, depending on your latitude, where you're at, north to south. Here it's a bit later, it's probably March, April. And then those young are born like many mammal species in the early summer. Their litter size is typically 5 to 7 or so. We can range though from like 2 to 10. They have pretty small home ranges. They don't typically stray more than a mile or two from their core area. They're not territorial in the sense that they don't defend territories from other skunks actively. If you've watched skunks, which perhaps many of you have, they're pretty chill. They're very lethargic. They kind of move slowly. And the reason for that is that they're not high strung. They have that scent that they can deploy as a defense mechanism. So we could all learn from that maybe and be more like skunks. They just kind of take their time. They're mostly solitary, but they may congregate a bit in dens during bad weather. Okay. They spray bad smelling things. We all know that. Their scientific name, Mephites actually means something like noxious vapor. Their spray is emitted through anal scent glands, which pretty much all mammals have, but they're not developed in this way. Dogs have these. That's why when dogs meet each other, they're sniffing each other's rear ends. But in the skunk, they're developed to where they can spray up to 10 or 15 feet fairly accurately. And there's a couple of chemical compounds in that spray that makes it so potent. They're similar to the compounds that are in decay, like decaying carcasses, or also in feces, and that's why it's so repugnant to us. The main chemical compound are called thiols, and there's another chemical compound in the spray that is actually activated by water. And so when you go to wash it off, it actually kicks in like a secondary bad smelling experience. And the idea is that this was an evolutionary adaptation to mammalian predators, that when they get sprayed, it's a bad experience. And then when they go to drink at a watering hole or they try to wash off, they get a reminder of that bad experience that just happened. The good news is the skunks don't want to spray. They give a lot of warning signs, and it is, an energetically costly activity for them. So they will hiss, they will stomp, they will raise their tail. If they're an eastern spotted skunk, they'll do a handstand. before they spray. So this is an eastern spotted skunk. There'll be a slightly better picture of this in just a moment. And they're up on their front legs doing a handstand, really showing out that that black and white coloring to try to warn before they do spray. However, some animals don't really get the memo. And I wanted to show this bears. This looks like a young bear to me, out foraging. I'm not quite sure where this is taken. I'm going to fast forward just a little bit here. Bears out foraging in a field. Oh, something's piqued its interest. Gonna go check it out. Bear heads over to a skunk. The skunk's got his tail up. It's warning. If you watch closely, you can see it stamp the ground here. There it is. It's rearing up. The bear is, what's the bear thinking about there? I don't know. I'm gonna go in. And it gets sprayed twice in the face and then runs away. So probably that bear's, well, who knows? Maybe that bear's first experience with the skunk. Maybe I thought it'd have better luck another time, but very, very effective defense technique. One last thing before we move on to the next part is there was this neat paper that came out in 2018, so a few years ago, documenting tool use, like a kind of tool use in skunks. This is images by Suzanne Dickerson, who's, by the way, really active on Twitter. I think she's called like Camera Trap Sue or something like that. And she has all these images of wildlife coming to her backyard. And she noticed the skunk is actually using a rock to crack the ice on this water source, and so that it can take a drink. And it tries, I mean, this isn't a video, so you kind of have to imagine, but it tries one rock and it didn't really work very well. And it went over and got a bigger rock, cracked the ice, and then was able to take a drink. So they are industrious and little creatures as well. That's interesting. Okay, so moving from natural history onto a recent study that we completed. This study was really motivated by a couple of different reasons. One is that despite them being common, they're in most of you all's yards. They're pretty understudied as a species, given that abundance. They're very important economically. You know, a lot of money is spent on pest control and damage mitigation. They're also disease vectors. They're probably the third most important vector of rabies, behind bats and raccoons. They're often stigmatized because of their smell, but they also play this important ecological role as a generalist predator. And they have this remarkable ability to thrive in the face of human-induced landscape change. And one other reason why we did the study is because no one had ever really done a large-scale study on skunks before. So we thought it would be an interesting thing to do. So our objective here was to look at a landscape level view of the factors that affect skunk abundance throughout the United States. And the way we did this is we took advantage of a project called Snapshot USA, which was developed by Roland Kays and Mike Cove, two researchers who had this great idea to bring together people from all across the United States and have everybody use a common method to put out these camera traps, wildlife cameras, trail cams, whatever you want to call them, that are depicted here. And so they recruited a bunch of researchers and collected all the information, put it together. And it's a really amazing project that lets us track, especially mammal species throughout the United States. And so that's the data set that we used. We contribute to this project here at UNH. We have 34 sites that are marked in these red and yellow circles here in the Bartlett Experimental Forest, which is run by the Forest Service, just north of Conway, New Hampshire, if you're familiar with the area. So we are contributing data to this effort as well. And what we did is we really wanted to look at different land cover types, different habitat types, and see what their effect would be on skunk abundance. And each variable we put into our statistical model, we had a reason to put in, and we had a prediction that was associated with it. So I'll just briefly go through some of these in our reasoning. So we put in cultivated lands, agricultural lands, and we thought that that would have a positive effect because it provides food potentially. edges between wetlands and agriculture are in the literature documented to be movement corridors for skunks, as are edges between forest and more urban areas. And that describes the skunk in my backyard very well, where there's this forested patch and then it's next to an urban area. And we think that that's providing a really good mix of habitats for skunks. So that would be positive effective as well. We hypothesize that big, large forest blocks would have a negative effect, possibly due to competition with other mesopredators for food and resources, maybe also increased predation rates by things like owls. We measured something called NDVI, which is like, you can think of it as just a measure of greenness, how productive a certain area is. And we thought that that would have a positive effect on skunks because it would provide more food. And then we had a few different urban variables that we were interested in. One was housing density, which we thought would be positively associated. One was impervious surface. So that would include houses, but also things like roads or parking lots or anything that's paved. And we weren't sure if that would be a positive or negative effect on skunks because impervious surfaces usually provide denning opportunities for skunks, but there's also associated with roads. So we weren't quite sure. We also had human population density as a positive potential relationship. We put in road density, which would be a negative relationship because of that vehicle collision as a source of mortality. And finally, wetlands, which might provide food sources for skunks. So these all went into the model along with a couple other things I'll skip over. And basically we wanted to see what came out as the most important. And we did some statistics, which is shown here that I'll spare you the details of, but in case you're interested, is the zero inflated end mixture model, which was very fun. And we analyzed that in a Bayesian statistical framework. And there was about 1,500 sites per year. So 1,500 different camera trap sites throughout the United States per year for 2 years. Those are the data we analyzed. So for the results, these are the things that mattered for skunks. These are the things that came out. The first and most important one, the strongest effect, was this NDVI index, which again is just a measure of greenness. It's how productive, how much vegetation production a certain place has. And that had a really strong effect on the expected number of skunks in an area. So this says covariate value. This would be like, to the left would be an area that's drier, less green, has less vegetation, and on the right would be a greener area with lots of vegetation. That seems to have a really strong effect on the number of skunks in the area. The second strongest effect was that impervious surface variable, demonstrating that connection between human structure and skunks. The third was agricultural land, cultivated land cover, but it's a pretty weak positive effect. There was also a positive effect between agriculture and cultivated land and wetland edge, but this purple is showing how much uncertainty there is in this relationship, and you can see there's a positive trend here, but there's a lot of uncertainty around it. And finally, contrary to what we expected, there was a slight negative effect of wetland land cover on skunks. If we take those results and put them into a model and predict where skunks are at all these sites, the map looks something like this. And so darker sites have more skunks at them. And so you can kind of see that in the west to east, there are fewer skunks generally, although those are some exceptions, as well as south to north. And the pattern looks roughly similar in both years of the study. So a quick discussion of some highlights. We found that skunks are really it's really all about food and den sites is how we interpreted these results. Where there's good food and good places to den, you're going to have a lot of skunks. Agricultural land seemed to be a little bit positive, but not as much as we thought it would. And as I said, that's really the denning sites and the food sources. So it emphasizes how skunks, again, are unique. They're occupying this very unique niche because if there's food and there's den sites, they'll thrive, even though many of the places they live are also populated by humans, which actively control them through pest removal and are one of the main sources of mortality through vehicle collisions. So it's this very interesting mix of positive and negative together. The impervious surface result is interesting because it suggests that it's really about the structure of human infrastructure. It's not necessarily population density or houses, but a more general category of impervious surface. And all they really need is skunks can den in pretty small spaces, actually, like underneath your stairs, for example, of a stairway to a porch outside. And so that presence of those structures really help them get a good den site. It kind of labels skunk as something we might call a synanthropic misanthrope, which is a term or phrase that Stan Gert came up with about coyotes, actually. And the idea here is misanthrope is something that's negatively associated with humans. Synanthropic is something that likes to be near humans. And this is kind of an odd combination of both of those things together is what skunks are. One other thing is we didn't see any changes in abundance across years, which kind of like highlights that idea that skunk populations are pretty constant. They're able to live in very changed landscapes. The last thing is this study really highlights the utility of a large coordinated study like Snapshot USA, which will now be in its 4th year. All right, I want to end just to take a couple minutes here and talk about skunks in New Hampshire in the Granite State. So we did a preliminary study in collaboration with Fish and Game, the Fish and Game Department here in New Hampshire in 2021 in the southeastern part of the state. And we put out wildlife cameras, and we also put out track or scent stations on the ground, which is like sifted sand, and that will collect tracks of animals. So this is me and my PhD student, Andrew Butler, putting one of those out. At those track stations, we put skunk essence, which is very pungent and smelly. It smells just like a skunk. When I ordered it to the offices here at UNH, the front desk person sent me an email like, what is this? What did you order? Because they had packed it in all the cellophane in this styrofoam box and then wrapped it all up, and you could still smell it. We had to store it, like we stored it outside under our porch. But a study out of Maine found that it was one of the better attractants for other animals, so that's why we used it. And part of the motivation was to see how camera traps and track stations compared to one another in their ability to track different animals. So some states like Missouri and Minnesota use these track stations to monitor populations of things like coyotes over time. And so that's part of the motivation why we did this study. Here's where we did it. We had about 75 sites that are these blue stars throughout southeastern New Hampshire. At each of the camera sites, we also had a transect of these track stations alongside of it. And I'll just show you some simple results from that. So we got a bunch of different tracks and a bunch of different animals, bobcats, coyote, foxes. Skunks are down here. And so the gray is, what we're doing here is on the y-axis is how the probability of their occurrence, like the proportion of sites that they exist at. So skunks are somewhere in the middle. They're at about 40 or 45% of our sites. We detected a skunk. And you can see that the cameras was a little lower, the track stations was a bit higher, and then this blue is putting both of those methods together to get an estimate. And so if you look at all these species, coyote and raccoon are the most common, almost at all the sites. And then bobcat, fisher, gray fox, possum, red fox, and skunk are kind of at about a little less than half of the sites. And so skunk fall into that category as well. We did actually find a negative effect of road density on skunk occurrence probability, and that perhaps reflecting that increased mortality risk. We also looked at the activity of different species at these sites. And so on the top is showing how active, what proportion of the day basically a species is active at. So at the very top, 100% would be it's active all the time, 0% it's active none of the time. And what we did is we compared sites that were exurban. They had a little bit more like, we kind of think of like suburban, rural, sort of developed sites versus sites that were more rural, like truly natural, to see if there's a difference in behavior in these two categories. And we didn't find any. Skunks don't care. They're active at night. They're very resilient. They don't really respond to humans in any way that we could see. We also looked at their activity patterns. So not only how active they are, but what times of day or night they would be active. And we also found no difference between exurban areas that have more development and rural areas. So again, just emphasizing the idea that skunks are very resilient. And this figure is really fun. I just put it in right before the talk because this morning, my student, Myri Poisson, who is the lead author on this, the paper got accepted into a journal this morning. So that's kind of fun. We've expanded the study across the whole state now, and we have very preliminary results, but we have about 300 different research sites throughout the state. We've detected about 1,000 skunk detections. Most of our detections, as you can see, are gray squirrels and deer by far, but still quite a number of skunk detections. However, they're very concentrated where people are. So in the southeast part of New Hampshire, if you're not from New Hampshire, that's where our quote unquote big cities are. We don't really have big cities in New Hampshire, but our bigger cities are in the southeast. And anything in yellow here is a site that detected at least one skunk. And so you can see the concentration in the southeastern part of the state. There are a few in the White Mountain region, and I suspect we will detect more as the study goes on, but you can really see that concentration there. So to wrap up, skunks are really interesting, such a fascinating creature, a kind of synanthropic misanthrope that likes to be near people even despite potential mortality from vehicles or pest control operations. And I really think that they're representative of the type of species that is going to thrive in a increasingly human-dominated world. They've found a way to survive and thrive living right alongside humans. And what enables them to do that is that generalist diet. They can switch their food types, they can take advantage of, they can be opportunistic, the changes throughout the seasons, and then they can defend themselves with their spray. So they're in this unique ecological niche. They're not at the top of the food chain. Apex predators have been removed in many different areas. That doesn't really seem to affect them. Meso predators like foxes and coyotes have increased in many areas. That also doesn't seem to affect them. They're just this resilient species that is out there. So before I think we have some time for questions, I just want to say thanks to a few folks. My co-authors, Max Allen and Austin Green, were the co-authors on that continental study. So I want to thank them. And then some of the work that we're doing in the state of New Hampshire, a lot of it is in partnership with the Fish and Game Department, as I mentioned, and the Ag Experiment Station here at UNH, and a bunch of students who are collecting data and landowners that have given us permission to do research on their land. So thanks for your attention. I'd be happy to take some questions.
Thank you so much. That was great. What a great job shedding light on an underappreciated and understudied species. So thanks, Dr. Moll. So we've got some questions here, and I think there's more rolling in. We had one about your figure, if you wouldn't mind backing up, where you showed the mortality effects on the skunks. And Kathleen was wondering about the white part of the bar graph. Was that, I thought it was disease, but I wasn't 100% sure.
Yes, it is disease.
Yes. Okay, cool.
Yep. And you can see here, it's interesting. So, and this is a pattern for a lot of species. Urban population, so there's two columns in each of these species delineations. And disease tends to be more prevalent in urban populations. That's most likely because they tend to be at higher densities. They get packed in more, and there's more transmission of diseases there. So this could include things. I mean, this can include all sorts of different diseases. I'm not really a disease ecologist, so I can't speak specifically, but it could be canine distemper, bacterial diseases. They get ectoparasites. They get mites. They get things like that. And so that's it. That's the major source of mortality for urban skunks.
Okay, and that relates to a question that Janet H had. She was wondering about distemper in skunks,
Yeah,
whether they could get it. And then she mentioned that in her town, they were having issues with raccoons with distemper.
yes.
So
Yeah,
one
they can
to that.
get it. I don't have a whole lot of insight into that, but they certainly do get it. And distemper outbreaks are fairly common in a lot of the canids and the coyotes and foxes and things like that, but they also occur. It also occurs in skunks.
All right, and Deborah Platt was wondering about skunks in warm places, whether or not they hibernate or they do not.
Yeah, so skunks, they're not true hibernators, so no skunks really truly hibernate like a bear would hibernate.
Mm.
They're more just inactive, and the reason for that is because of food, primarily. So if there is access to food, they'll remain active. And even bears will do this to a degree, black bears. So you get black bears in more urbanized areas. It's a little warmer because of all the paved surfaces, or they found a really good den underneath someone's house, and they won't really truly go into a hibernation either. So, my experience with skunks is fairly limited. I don't know specifics, but I would guess that skunks in southern locations are actually fairly active throughout the winter, and then they'll just hole up if there's a storm, if there's a winter storm that occasionally occurs. They have those dens, and they'll just wait it out and rely on those fat stores, and then when it passes, they'll come back out to eat.
Interesting. Such lots of variation here.
Yes, they're very flexible.
Yeah, and there was a question about that. That's something that I talked to you about before the Zoom, was talking about how there's a lot of difference in how wide the white stripe is.
Right.
And someone noticed, I'll have to look for who noticed, that there's almost some skunks that appear almost purely white. And they were wondering, is that still the striped skunk?
Yeah, they typically are still the striped skunk. There's huge variation, as Karen is saying. Some of them almost look completely white, and but I've seen the opposite as well, where they just the one thing that the feature that seems to be constant is they have that stripe down. You can see it on this picture. They've had the stripe down their nose, so that's pretty common. But the degree to which they have those two sort of splitting racing stripes varies a ton, and it's I'm sure it's genetic, and there's just a lot of natural variation to it, but they're probably still striped skunks. Yeah.
Cool. That question was from Heidi S. Thanks for that, Heidi. And then Patrick McGee was wondering about, we had a couple questions about pets and skunks and interactions. And Patrick was wondering about if you know anything about the relationships that skunks have with house cats.
Oh, yeah, interesting. I don't think it's a friendly relationship. Cats are curious, and we'll check them out, but I think cats are pretty smart as well. I would guess that cats get sprayed a little less than things like dogs. I don't know if that's true or not, but that's just an anecdote. I mean, the main thing is that, like, when you think about pets interacting with skunks, two things. One is skunks can have rabies, and so if your animal is bitten, or you think that your animal might be exposed to wild animals that might have rabies, then vaccinations should certainly be a consideration. But rabies is contracted through saliva, so there has to be a bite. You can't get it from the spray. And then the other thing is, the sort of, I think I saw this in the chat, so this is probably already answered, but the tomato juice thing, where you give a tomato juice bath, that's not really a thing. It's sort of a myth. What I've heard worked best, I haven't had to do this, thankfully, for any of my family or my pets, but hydrogen peroxide and baking soda mixed with a little bit of like dish soap is the best, but hydrogen peroxide also dyes hair, so it should be pretty diluted unless you want to like dye your pet's hair. But that neutralizes the chemicals. It oxidizes the chemicals in those thiols, and will help reduce the smell
Mhm.
much more quickly than tomato juice or water.
I can attest to that. My dog has gotten sprayed a few times, and the hydrogen peroxide, I always keep some in at home for that exact reason.
Oh yeah, did it work?
Yeah, it works great. It's
Yeah.
just don't get them wet. It's like a gremlin. Don't get them wet.
Yeah.
Because like you mentioned, there's such a difference. The first time she got sprayed, I didn't know that, and boy, I wish I did, because it's so powerful. One of
Yeah.
the questions I had along those lines was, it's such a powerful predator deterrent. I wonder why we haven't seen this evolve in other taxa.
Yeah, that's a great question. I don't know the answer to that. And it does speak to that unique, like, phylogenetic
Mm-hmm.
tree of the skunks, that they really are their own thing. I mean, I imagine part of it is it's a fairly complex chemical,
Mm-hmm.
and it's relatively costly to produce, perhaps, like it requires a lot of energy, but it
Mm-hmm.
seems to work really well. So I don't know. That's a great question.
Yeah, cool. Okay, Dan was wondering, he's our friend from South Dakota, and Dan was saying that out there's an effort to increase the pheasant populations. There's predator trapping programs where they pay bounties, often to kids, in an effort to decrease the nest and chick predation. And Dan's wondering if you have any comments on that.
Yeah, I mean, they certainly, skunks and other skunks are probably not the most uh, taking pheasant or other eggs at highest rates, or young animals. I would imagine it's probably coyotes and foxes and things like that. A lot of these meso predators are very resilient. So not just the skunk, but foxes and coyotes as well. And so removal programs, I think, it can be hard to really make a dent sometimes. You can remove, say, coyotes at a fairly high rate, and they'll just reproduce and recolonize. So it can be a bit like, failing water in a boat while it's raining or something like that. But it could have a positive effect. I don't think that it's unfounded, and it does bring up ethical concerns, and people fall on different sides of, should we be doing things like that. I don't really have a strong stance on it. I think scientifically it could increase survival of birds if it was done at a very high level. But taking a few predators here and there is probably not going to do very much.
Okay, thanks. Taffy from Alstead has a couple. I'm from Alstead too, so hey, Alsteader. Taffy had a couple observations. She once said, these were two separate things, but I thought I'd pitch them once to you. She noticed a toad skin, and she wondered what animal might have eaten the toad that would skin a toad before they ate it. So that's a mystery. And then also she's wondering if skunks would eat the invasive worms. I assume she means the invasive jumping worms that everybody's talking about.
Yeah, I don't know specifically the answer to the jumping worms. I assume they would. I think they will eat anything. So I bet they would, and that would be an interesting little study to do to see if they could act as like a biocontrol. With the toad, yeah, I mean, that could be any number of things. I didn't mention, but skunks do eat amphibians, reptiles, toads. Basically, they kind of just, as I said, they sort of just like hunker and like meander almost as they forage. And so they sort of like sneak up on things, and anything they sneak up on, they'll eat. Whether or not they skin a toad and not eat the toad's skin, I don't know. Maybe somebody else in the chat knows. I don't know.
That sounds like a hard one to know, and you need one of your wildlife cameras, I think, to maybe get at that.
But yeah, we could put, we could bait it with the toad and see who comes along.
Deborah and Linda were wondering about skunk lifespan duration.
Yeah, thanks. That's a good question. They're fairly short-lived. I don't have a number of that I'm aware of for their average lifespan, but I think in the wild, you're probably talking mostly 3 to 5 years would be my guess. I don't think they're a long-lived species in the wild. They have pretty high reproduction. They have those the skunk kits, 6 a year, potentially more. So they have a high reproductive capacity, and I imagine that they're not too long lived. But perhaps, I don't know if anybody in the chat has skunk as a pet. I imagine in captivity they can live quite a long time, more similar to something like a cat.
And how about the size of a skunk's home range? Deborah was asking about that as well. How much?
Yeah, they're pretty small. So like a ½ kilometer squared would be the smallest, like a 500 by 500 meter box, kind of imagine. Or you can kind of think of it, they usually don't range more than a mile or two from their central den. So they're pretty concentrated.
Okay, and then another one here about distribution. Janet was wondering if they're more concentrated in areas of turf or lawns because they might have an easier time digging for prey.
Yeah, I think they do favor lawns in certain parts of the year. But it's really going to come down to, is there shelter nearby? Is there a site where they can have a den where they can retreat to rest, to raise young, to live in over the winter? And if that den can be located in an area that's near lawns, then you're certainly going to see them out on those lawns. So I'm here, if anybody's familiar with UNH, I'm here in James Hall. And the other night I left at like 5:30 in the winter and walking along the sidewalk in front of James Hall. And there's just a striped skunk just trotting along in front of me. It doesn't care that I'm there. And I bet it's living its best life. It's found some place to den underneath, one of our buildings, and it's coming out to those lawns at night to look for grubs and worms and things like that.
We have quite a number of campus skunks here at Keene State as well.
Oh yeah.
Oh yes, I love to see them toddling along, and it's true. I love how they move at their own pace, and that's
they do.
Yeah, and that's kind of fun because, so like you mentioned, so many other wildlife, they avoid humans, and it's nice to have one that doesn't. Jacqueline had one cool question. Maybe this will be our last one. Was how long it takes for a skunk to regenerate their spray after they have emitted it?
Yeah, that's a great question. So it's on the order of about a week, I believe.
Oh wow!
And they can spray a number of times before it sort of needs to be replenished. 4 to 6 times. I think in a given encounter they'll spray once or twice. So they can keep them in reserve a little bit, but there is sort of a latency time to build it back up. Yeah. And I was also going to say, your comment about campus skunks. Skunks are also a great species. Like if you are in an urban area that gets snow, after a light snowfall, it can be fun to go look for tracks, because their tracks they're kind of irregular, and you could like look up what they look like online. But they use areas right around people's houses all the time, and they're out at night, and so they're really close. And so it can be a fun activity to try to find skunk tracks after a fresh snow in an urban place, or in a rural place as well. But
that's a great idea. And I always have students tell me about their skunk sightings because they're often out at night at the same time the skunks are. So I hear more a lot of reports of those encounters, which are great. It's they're a cool animal, and you really brought a lot of points about how they provide a really important ecological role, and they are getting along quite well, which is not the case for a lot of species. So that's something to celebrate, I think.
Yeah, absolutely.
And Doris mentioned as our fun fact on our way out is that her grandma's descended pet skunk lived for 12 or 15 years.
Oh, 15. Okay.
Oh,
yeah, that's great.
That's pretty remarkable. So thanks again to our speaker. Thank you, Dr. Moll. I'm sure we'll all be dreaming of skunks tonight. And thanks to all of you for coming. It was a lot of fun, and I hope to see you in the future at another Hair Center program. Happy spring and happy summer, y'all. Take care.
Thank you.
Bye.